So this is a multiplexer. First we have to know what is the multiplexer, and from multiplexer and then decoder it is come to the closer by just little bit modification that we are coming slowly. Multiplexer, it is a combinational logic circuit with many input channels and selects only one channel to the output channel. It has many inputs but one output. Many inputs are there are so many inputs and only one output. So here you see there are you can see that it is type of decoder only. We just modified the decoder. So decoder it is there. Actually here our multiplexer main target is somehow we have to include many channels, and then you will be getting that so that proper instrument can be utilized. Like that way, if you see the networking, when you in the internet cafe, you see there are only two this one the telephone lines are there, and 50 or 100 fellows are working there, or 50 fellows are working there. So how it is there? That type of that switchboard is there. The switchboard is just nothing. It is a multiplexer only. So there are many people you can connect, but there will be only one output channel. Means it is going to the outside world to connect it, because that is a telephone line will be connecting. So here what we have done, this is just exactly same thing. We have done decoder circuit, we have done same thing. Here only extra input line we have added here, extra input line, and all this output is put in a OR gate. Put in a OR gate means at a time signal may come from so many places, from here, anywhere, here. There are so many probabilities are there to come to the input channel, but only one communication channel to the outside. So that is our this one this is the 4x1 input. This one 4x1 multiplexer with one output channel. So it is 4x1. You can say actually here there are 1, 2, 3, 4 direct input we take. That's why we call it a 4x1. But output is 1. 4x1. So this is the logic circuit. This is logic circuit of 4x1 multiplexer with one output channel. So this is the 8x1 multiplexer with 3 control lines. 8x1 multiplexer, you see there 8x1. 8x1 means just the truth table we draw it. Truth table the 8x1. That be, and here that be 3 means the 3 inputs should be there. That's why C0, C1, C2, C3, or C0, C1, C2 you can write it. And now here C1 and complement, C2 complement, C3 complement. There are 3 are coming. And now from that extra input line you are giving I0, I1, I2, like that way we are giving input line. Extra line we are adding with that, so that more number can, more channels can be added. And then all these output coming here, it is already 3 variable truth table have already I have given you. This is the 3 variable. So 404120, like that way it is coming. Here you see here the input I am taken from here. This is the C ordinary or not complement. That means here it is C1, and here it is C2, and here it is C1, C2, and here it is C3. This one, all 3 are not covered. That means here it is 1, 1, 1 signifying. Now like that way it is coming here. This is 1, then this is 1, and this is 0. This is 1, 1, 0. And this is 1, 1, 1. This signal is coming. Now here also coming with a 1, then here it is 0, and here it is 1. 1, 0, 1. Like that way, if you will get the 3 variable 8 arrangements are there. That truth table you will be getting. On the basis of that only it is drawn, and then all the output will come and passing to an OR gate, and this is your output. You don't have to draw all this, just you have to draw nicely so that you don't make mistake. But you have to keep in mind this order, so that when you are drawing it here, from there where you have to get this input, and from where the source you must highlight like this a little bit. So these are the source. So this source you have to highlight, so that when the examiner will check, will say that source have been taken in correct location or not. So this was. So this is a decoder circuit, you can see it here. Convert the decoder circuit to gate multiplexer. That I told you little bit when I was drawing the multiplexer. So this is your decoder circuit. Here this is output, you can say D0, D1, D2, D3 like that are there. So these are the output. Now this is a perfect decoder circuit. Now we are modifying into the multiplexer. What we are doing, we are adding extra input line. So from outside these are the two lines. It can give maximum 2. This is A and A0. B can give also 2. B and B0. Now they cannot give any more. Now what I am doing, I am adding one extra input line from outside. So to get the multiplexer circuit, just we are modifying it. The question came once, how to modify the decoder circuit to get a multiplexer. So this is, you can give it, you can try I0, I1, I2, I3. This is just nothing. This is just the extra input signal I am taking it from outside. So this way you are taking. We cannot take from here. We cannot take from here. We cannot add also. If we add, then it will be 3 by 8, something like this. And now here it is only 2 input. So extra input line I am taking it. And now all this, whatever will come, all these channels, so that will pass. Here I am, in decoder, this is all passing. This is your output in case of decoder. But when it is a multiplexer, we are modifying it. We are passing into a OR gate. So this we are going, and this became now multiplexer. Just two modification. Here I added one extra line to get more signal, and there all the output we are passing through, and this one on a OR gate, so that there will be from any source. OR gate means from any source the signal comes. All are capable, because it says in a cafe there are 50 fellows are there, and then they all are trying to open the internet. Then what will happen? The multiplexer, whoever asking first, whoever clicking first, whoever demanding first, that will be entered. So there are from so many channels, from so many ways signals are coming, but the multiplexer will decide who actually demanded first. That will be there, but at a time one. So that is actually to increase the more signal, and we are passing to one output channel, that is your this one we are passing. That's why we are using the OR gate out here, so that anybody can try, not AND, but according to the priority they will get the chance. So that is your modified version in the decoder, and these I have given you in the notes, and even the clarification description are also there. This is important because it came 2-3 times in the board exam, how to convert, how to modify. So actually this is the modification part.